Saxon Algebra 1/2, Lesson 109. Caleb, we are making fantastic progress. We're getting close to the end of the year. Let me show you. Today is May 19th. These are the lessons that were due, that you have due today. These are the lessons that I taught you last week. So as of today, we have 3 more lessons, 3 more weeks of new lessons, and then our review and final week. These will work exactly like the midterm, where I'll make you a video telling you which lessons to study, and then I'll take the test by dropping it on your front porch. You'll take it, you'll send it back to me. All right, so that's just a picture of where we're going. Some of the lessons that we're going to be covering here, I may even jump around a little bit. I am not exactly sure. Yeah, I'm just flipping in your book right now looking. Yeah, your book goes up to 123, so I may adjust these ever so slightly. But what you'll notice is that some of these topics seem a little weird, like we're starting today with a couple of business-related topics. That's okay. They don't necessarily relate to the heart of what we've been doing all year, but they're interesting, important topics, even if they are a little bit sideways. So don't worry about that. It'll be kind of, I think, a relief, a break on your brain. It'll feel a little different. Today we're going to talk about interest. Interest, as you well know, is what banks and other financial institutions pay their customers for letting the bank use the customer's money, right? When you put money in the bank, it doesn't just sit there. Your bank uses it to invest even overnight in different savings instruments, and your bank earns money by using your money. So they give you a cut in those proceeds, and we call that interest, right? Now, there are 2 simple kinds of interest. There's 2 kinds of interest. One is called simple interest. I said that wrong. And let's just pretend that we live in a beautiful fantasy world where you get paid 10% per year on your money. Banks don't pay that much, I'm sorry to say. But let's just pretend, because 10% is a nice, easy answer. That means if you put, say, $100 in the bank at the beginning of the year, you would earn, by the end of the year, you'd still have your 100, plus they would pay you $10, 10% of your original amount, right? This is year 1. At the beginning of the second year, you would have $110 in the bank, but they would pay you another 10. They would only pay you on your principal, your original amount. So then you would have 100 plus the 10 of the first year plus the 10 of the second year. They're just paying you on your original investment. The third year, you would have 120 in your bank account, but you would get paid just on the 100. So you get 10 for the first year, 10 for the second year, 10 for the third year. They're only paying you on your original amount. Okay, so let's look at a couple problems with these using simple interest before we move on to the next kind. Jim put $5,000 in the bank for 2 years at 8% simple interest. How much money did he get when he withdrew his money after 2 years? Okay, so we can use this same format. At the beginning, he had $5,000. That's the beginning of year 1. He would get 8% of that. So let's multiply. I'll do it over here. 5,000 times 0.08, because that's 8%. 0, 0, 0, 40. 2 digits behind the decimal place. So that means he gets $400, right? So at the end of the year, he'd have his original 5,000 plus he would have 400, right? At the beginning of the second year, he would have $5,400 in the bank, but he's only getting paid on the original amount. So at the end of the year, he'd have the interest for the first year plus the interest for the second year, and that would equal $5,800, and that's the correct answer. Put a $sign on there. Okay? So with simple interest, you get paid on your original deposit, but you don't get paid interest on your interest, if that makes sense. Let's do one more problem before we come to the real world. I don't know of any place that pays simple interest. That's a very outmoded concept. It's a simple idea, and that's why we talk about it first, but this is not the kind of interest that you see in the real world. Okay, Maria deposited $800 at 8% simple interest. At the end of 3 years, she will have how much money? Okay, beginning, end, 1, 2, 3. She started with 800. At the end of the year, she'll have her original 800 plus she's going to get her interest. I'll do this one over here. It's 800 times 0.0800064. Whoops. So she gets $64. At the beginning of the second year, she has this much. This column might seem like I'm doing something weird over here. Like, why am I putting it together and then taking it apart? You'll see when we get to the compound. There's a method to my madness. At the end of the second year, she gets the 60. She still has the 64 from year 1, plus she gets another 64. And that makes it what? 928 that she has, if I add all this together, right? 128, 928, okay. So then this year she has 800 plus 64 plus 64 plus 64. So that is, I'm adding it all up in my head sideways. 4 plus 4 plus 4 is 12. So I carry the 1. 6 plus 6 plus 6 is 18, 19, 992. Is that right? Yes, this is how much money she has at the end of 3 years using simple interest. Okay? You get the same amount of interest every year. These are way easier math problems. Now we're going to flip the page and we're going to talk about what happens in the real world, which is much better for us, the consumers. This is compound interest. And the easiest way to think about this is, I spelled that wrong, interest, is you get paid interest on your interest. Interest. 2. With simple interest, you only get paid on the amount you deposited. That number is called your principal. In compound interest, you get interest on your interest. Yay, that's much better. So let's look at, there's only one example of these. How much will $700 be worth in 2 years if the money is deposited at 9% compounded annually? So that tells us we're using compound interest. That calculation's a little different. Remember last time we got the same amount of interest every year, and it was based on the deposit. It had nothing to do with the interest we'd earned in previous years. So let's make another one of them little charts like we had. We only need 2 years in this. In the beginning, who is this? Oh, there's not a person attached. I think it's Bonita. Should be our investor at this point. She started with $700, and so at the end of the first year, she earns 9%. 700 times 0.09, that's 9%. 63. So she gets $63. So that's 700 plus the 63. Now, at the beginning of the second year, she has $763. At the end, her interest is calculated not on the original amount, but the amount that she's had in her account all year. So it's 763 times 9%. Makes sense? Kind of. 27, 56, 63, 68. 2 decimal places. So she would get, oh, this is a 7, sorry. It's 27. She would get this much interest because she's getting paid interest on last year's interest, assuming it's still left in her account. So this time we add 68.67. Makes sense? The amount at the beginning of the year plus that year's interest. The amount at the beginning of the year plus this year's interest, which is more because we had more in our account. And then we just have to add these together to get our final answer. $831.67. That's our final answer. Okay? So compound interest is mathematically more of a pain in the neck because we have to calculate a different amount every year, but it's a much better investment deal. So that is lesson 109. We're going to continue these business-related lessons for a couple more. They're kind of a little change of pace, aren't they? But they're super practical, super useful. And for someone like me who went on to study accounting in college, it gives you a glimpse into a different kind of math, a business-related math that I found really interesting. So anyway, it's a change of pace, and we'll continue it with lesson 110. Thanks. Bye.